Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P16E2 specifically refers to a PGM-FI-ACG LIN communication error in the Honda Civic 2022 and newer models. This error indicates a malfunction in the communication line between the engine control module, ECM, and the alternator, also known as the ACG, alternating current generator. When the Powertrain Control Module, PCM, fails to receive signals from the alternator through the local interconnect network, LIN, it registers this anomaly and triggers the error code. Components involved in this communication failure involve the alternator, the LIN circuit, and the PCM. The location of these components is vital. The PCM is typically mounted within the vehicle cabin. The alternator is found in the engine bay, and the LIN runs between these parts. Understanding the roles of each component is key to effectively troubleshooting this error. DTC P16E2 signifies that the Powertrain Control Module, PCM, is not receiving the necessary signals from the alternator via the local interconnect network, LIN. The PCM's inability to interpret these signals indicates there's a communication failure, which leads the vehicle system to flag this specific trouble code. The alternator is responsible for generating electrical power for the vehicle, and the LIN circuit facilitates communication through a single wire that connects both the PCM and the alternator. A proper functioning alternator sends essential voltage and data signals, which the PCM requires to manage various vehicle functions, including engine performance and battery charging. The location of these components is critical in the troubleshooting process. The alternator resides in the engine compartment, while the PCM is usually found beneath the dashboard. Any issues in this communication line can impede the vehicle's electrical system and trigger this diagnostic code. Several factors may trigger DTC P16E2. The most common cause is a loose terminal connection at the alternator, particularly the ACG plus B terminal, which can interrupt communication. If the alternator itself is faulty, it may not produce or send the required signals, resulting in code P16E2 being stored. Another potential culprit is the LIN circuit. If there are breaks or malfunctions in this communication wire, the PCM will fail to receive critical information from the alternator. Lastly, if multiple inspections point to operational components, the PCM itself may be at fault, indicating an internal issue. It's essential to thoroughly check each of these possibilities as part of the troubleshooting process to determine the root cause of the problem. Understanding the symptoms associated with DTC P16E2 is vital for diagnosing the issue effectively. Drivers may notice dashboard warning lights illuminating, often indicating electrical problems, as the PCM struggles to manage power distribution without reliable signals from the alternator. Additional symptoms might include a discernible decrease in engine performance, as the vehicle's electric systems could malfunction due to insufficient power. In some cases, vehicles may experience electrical failures, such as flickering lights or unresponsive electrical components. If left unaddressed, these symptoms can progress, leading to more significant complex issues down the road. Therefore, interpreting these initial signs correctly aligns with timely diagnostics and repairs. The first step in diagnosing DTC P16E2 involves turning the vehicle's ignition to the on mode and allowing it to sit for 10 seconds. This procedure enables the Powertrain Control Module, PCM, time to initialize and check for existing fault conditions, providing an initial assessment of the system's operational status. It's during this time that the PCM communicates with various components, such as the alternator and LIN circuit. This wait period can help to refresh and reset any temporary glitches that could have contributed to the error code being triggered. Following the waiting period, It is significant to monitor any warning indicators or issues that may still persist. This simple yet essential step serves as a foundation before delving deeper into more complex diagnostics and troubleshooting procedures. In the second step of the troubleshooting process for DTC P16E2, one should inspect the ACG plus B terminal of the alternator for any loose connections. A loose terminal can disrupt the electrical signals transmitted between the alternator and the PCM, causing the communication error. This inspection is crucial because it could be a quick fix if a simple tighten resolves the issue, eliminating the need for more extensive diagnostics. When checking the terminal, ensure to examine both the physical condition of the terminal and the wiring connected to it for wear or damage. Once the terminal is secured properly, the system should be powered back up to see if the DTC reappears. Efficient identification of this issue could save significant time and effort in unnecessary repairs. The third step focuses on inspecting the alternator's functionality. This includes performing specific circuit tests to ensure that the alternator is generating the necessary output and that it's functioning within its normal operational parameters. Utilizing a multimeter or specialized diagnostic tool will allow you to measure voltage output and inspect for correct indications. Should any irregular readings arise, it might signal that the alternator is defective or has internal failures. Continuous faults in alternator performance will directly lead to issues in communication between the alternator and the PCM. If the alternator fails the circuit tests, replacement or repairs will be required to re-establish proper functionality. This step is crucial in eliminating one of the primary potential causes of the DTC P16E2 error. In Step 4, the goal is to inspect the integrity of the local interconnect network, LIN, circuit. This involves checking for any physical damage or breaks in the wiring, as well as inspecting for potential short circuits that could interrupt communication. Performing a conductivity test along the LIN pathway is crucial to confirm that signals are passing properly between the PCM and the alternator. Identifying shorts or open connections can often require using specialized equipment to trace the circuit accurately. If damaged aspects of the LIN circuit are found, appropriate repairs should be carried out to restore its functionality. This step is essential because it directly correlates with the communication problems underlying the DTC P16E2 error. The fifth and final step in the troubleshooting process for DTC P16E2 is to examine the operation of the PCM itself. This involves performing diagnostic tests to confirm its functionality and determine if it is indeed malfunctioning. If the previous inspections of the alternator and LIN circuit show normal conditions, then it may point toward an internal PCM issue. The use of specialized diagnostic tools can help verify if the PCM is processing signals correctly and managing communication with other components. If the PCM fails tests or shows persistent error codes, replacement may be necessary to resolve the issue effectively. It's vital to ensure that all aspects of the troubleshooting procedure have been completed to avoid premature replacement of the PCM without addressing underlying issues. After addressing the underlying issues and completing the troubleshooting for DTC P16E2, it's time for final repair verification. Start by clearing the diagnostic trouble code using the Honda Diagnostic System, HDS. This action resets the vehicle's onboard computer, allowing it to remove the error code from its memory. Following the code clearance, it is essential to perform a test drive of the vehicle to assess if the problem reoccurs. During the drive, pay attention to any warning lights and monitor the vehicle's performance to see if it operates within normal parameters. If no issues arise post-test drive, it suggests a successful resolution of the initial problem. However, should the DTC return, it may require a reassessment of the previous inspections and possibly further refinements in the repair strategy. Preventive maintenance plays a crucial role in avoiding DTC P16E2 in the future. Regular inspection of electrical connections, particularly at the alternator and PCM, is key to ensuring that everything remains secure and free from corrosion or wear. Establishing a routine maintenance schedule that incorporates these checks will help preemptively catch issues before they escalate into major problems. It's also beneficial to periodically examine the LIN circuits for any signs of damage or degradation, as well as ensuring appropriate voltage levels are maintained. Educating vehicle owners about warning signs relating to their electrical systems can further help to avert potential failures. Proactive care of these components can lead to a more reliable vehicle operation. In summary, DTC P16E2 represents a PGM-FI-ACG LIN communication error that can disrupt vehicle performance significantly. The primary focus in troubleshooting this error involves inspecting the alternator, the LIN circuit, and the Powertrain Control Module, PCM. Accurate identification of the root cause allows for timely repairs and helps restore proper vehicle functionality. Additionally, implementing preventive maintenance routines is essential for long-term reliability, which includes regular inspections of wiring and connectors. By understanding the components involved and effectively addressing issues as they arise, vehicle owners can ensure better performance and minimize potential disruptions. This comprehensive approach reinforces the importance of both reactive and proactive maintenance strategies in modern vehicles. Please like and subscribe to the channel. See you next time.